Hello, everybody, and welcome back to another visual pattern challenge. We've got an interesting one today. Here's step one, here's step two, here's step three, and your challenge today is to predict not how many boxes, but the dollar value of all the boxes in step four. If you can do that, can you predict the dollar value of the boxes in step 43? And can you write an equation that could be used to predict the dollar value in any step at all? If you'd like to accept that challenge, pause the video and see what you can do. So this one is a little different than we're used to. We've got, a visual pattern of these boxes, and I think we probably have the skills to predict step 4 and maybe figure out step 43. But then we've got this dollar value to kind of complicate it. So the final answer we're looking for really is the pattern, the number of boxes, multiplied by whatever dollar value is going to be in those boxes at that step. So we'll have to figure that little extra piece out as we go along here. I think we should do that in two parts, though. We should figure out how many boxes are going to appear in the next step and in step 43 first, and then worry about multiplying it by the dollar value. So let's see, just looking at the number of boxes, I've got a 2 by 3, and then a 3 by 4, and then a 4 by 5. So I think this should be 5 by 6 box, right? So that would be 30 boxes. And then the dollar value goes 199.98. So looks like we're going to multiply that by $97. So 30 boxes of $97 each. So 30 times 97, that's going to be, wow, that's a lot of money already. $2,910 is what I'm getting there. So that's my prediction for step 4. And so for this particular piece, I don't think I even want to make a list of the numbers to analyze them. I think it's pretty clear that this is a quadratic pattern. And the reason I say that is that we have these rectangles that are growing in 2 dimensions at once. So that gives us a second degree equation. And I think just from the visual insight here, we can get an equation for that rectangle, for the number of boxes. It looks like, we're 2 by 3, 3 by 4, 4 by 5. It looks like we're going up 1 in each dimension to start with. And the dimensions are, well, this one is 2, so that's the step number plus 1 on this side. And then here, it's the step number plus 2. So 2 by 3. So 1 plus 1 is 2, 1 plus 2 is 3. And the same thing happens here. X plus 1, 2 plus 1 here would be 3. 2 plus 2 here would be 4. So I think those are our dimensions. And then to get the number of boxes, we just multiply those. It's the formula for the area of a rectangle, length times width. So I think our equation for the number of boxes is going to be x plus 1 times x plus 2. So that's the equation for the boxes. And then we have to multiply it by the dollar value, and we can figure that out in a minute. I'm just going to FOIL this out. So let's see, that would be x squared and a 2x and a 1x, so plus 3x and plus 2. So that's our equation for the number of boxes. Now what about the dollar value? Well, it looks like it starts in step 1 at 100 and it goes down by $1 every step. So to get 100 in step number 1, I'm going to need to subtract because I'm going down. I would say this is 101 minus the, 101 minus the step number. So in step 1, I put a 1 in for x. That would give me 100. 101 minus 1 is 100. And in step 2, 101 minus 2 would be 99, and that's what the dollar value is. So our whole equation then is going to be times 101 minus x. Now, you could multiply this out and get a cubic equation with a negative first term, which is kind of strange. We haven't really seen that very often, a negative leading term. It makes sense though, right? Because if you extend this series out beyond 100 steps, the dollar value would go negative, right? So eventually you'll have a negative value for this function. So I think instead of multiplying this out, I think I'm going to leave it like this because it tells me a little bit more about what's really going on in the function anyway. So this is one of the more complicated equations we've had. So I'm just going to not complicate it further by leaving it like this. So 101 minus x. Okay. So I think we've got our complete equation. We could test this with each of these. I'm not going to. I'm going to let you do that if you'd like to. I would test this chunk to make sure it's predicting the number of boxes. It is. I'm confident of that. And I think this part you could test too. It's pretty clear that 101 minus 2 is 99, 101 minus 3 is 98. So I'm not going to bother to test that part either. So the final step then is to plug in step 43 for x in our equation. So this is going to be 43 squared plus 3 times 43 plus 2, all of that times 101 minus 43. Okay, so what is that? 1849. 3 times 43 is 129, and then plus 2. So let's see, that's 1980. And then 101 minus 43 is 58. So we're going to multiply those. And I am getting $114,840. Might want to double check my calculations on that one, but that's what I'm getting. So in step number 43, $114,840. Well, how did that go for you? Did you get this 2,910 for step 4? Did you come up with an equation on this one? I think this was pretty involved. Let me know how it went. Thanks, everybody.